Hi, everyone. Welcome to Cloud Native Live. Today is Thursday, May 16th, when we're recording this. Welcome to all those who are joining us. My name is Taylor Thomas, and just as a normal thing that we talk about here at the beginning, this is a CNCF related event, and as such, it is governed by the Code of Conduct. So please make sure just be nice to people and keep your comments kind and civil as we go throughout this stream. So in Cloud Native Live, we get to talk about the technology behind Cloud Native. And besides just being a host like I normally am today, I'm also one of the presenters. And I'd also like to introduce my fellow presenter, Jeremy. Jeremy, you want to introduce yourself a little bit?
Hey everybody, my name's Jeremy. I work at Synadia, and we maintain the NATS.io project, which is one of the older CNCF projects, but it has a lot going on, and we do all kinds of stuff. So I do a lot of stuff at Synadia, from creating videos and developer-focused content to a host of other things: product development, open source development, things like that. So glad to be on here. It's going to be fun.
Yeah, awesome. Thanks for joining today, Jeremy. And today we're going to be talking about a lot about NATS and also about a project that I help maintain called Wasm Cloud. They're quite synergistic projects, and so we're going to talk a lot about that today. But first off, Jeremy's going to kind of give a deep dive into this because it's the foundational technology of a lot of what I'm going to talk about. So let's go ahead and let Jeremy take it away.
All right, excellent. I'm going to assume I'm not. I'm trying not to assume a lot during this conversation, but one of the things that we really wanted to jump into was this concept of NATS Jetstream, and so a lot of this conversation is going to be covering what Jetstream is, but I'll talk a little bit about what NATS is as well as a project, and so because I think that's going to help give you a little bit of context. Like I said, NATS is one of the oldest CNCF projects that's been around, and so one of the challenges that we have is that NATS has evolved so much over the years, but plenty of folks will still be like, "Oh yeah, we know NATS. It's how we knew it." 8 years ago or 7 years ago, and it's actually changed quite a bit, and the use cases that NATS is able to solve for have just become extremely abundant, which has been really, really fun for us because we get to solve a lot of hard problems, especially when it comes to like largely distributed systems. Today, we're mostly going to cover what NATS Jetstream is, which is a subsystem in NATS that allows for persistence. And so, in order to talk about Jetstream, we first want to talk about what the heck is NATS. We tend to break NATS down into a couple different subsystems of the patterns of how NATS works. But at its heart and soul, NATS is a messaging system where you send messages to a NATS server, and that NATS server brokers communication or messages between multiple clients. And so you can think of NATS as a way to have microservices communicate with each other, or being able to kind of like send data in a persistent way, being able to kind of move data around. And the really neat thing about NATS is it's multimodal in many, many different ways, from being able to just run it as a single server, maybe on a Raspberry Pi, all the way to being able to scale this up into like a global deployment where you have this constellation of NATS servers that are all connected to each other in interesting ways. And being able to kind of have those NAT servers everywhere really creates this idea of location transparency, meaning I can have a microservice or a service or some sort of application that can connect into the NAT server and can talk to any of my other applications, no matter where they are, no matter where they live, no matter what cloud they live on, or that the fact that they may be living on a device at the edge or living on a phone. It really doesn't matter, where those things live. They are able to communicate with each other because NATS is brokering all that communication. And so there's a lot of different patterns that NATS can cover, and I'm going to try to cover a lot of the ones that are related to NATS Jetstream. But let me talk about core NATS for a second, because this is kind of the foundation of what NATS is based off of, which is sending a message, being able to publish a message and subscribe to a message. So on one hand, you have a client over here, And by the way, clients can be in pretty much any language. We have language bindings for dozens and dozens of languages. And we officially at Synadia, we support about 12 to 13 of them. So pretty much your language of choice is going to be supported here. But you have these client libraries that can publish to a NAT server or a cluster of NAT servers. And then on the other end, you might have a subscriber that's subscribing to that. And the cool part about this here is back to this location transparency bit, is really they only need to know the address of the NATS server. They don't need to know, who they don't really need to know or care about who's subscribing to the message that they're sending. They just simply publish the subject and the payload of the message, and that payload gets received by the subscriber. So this is really good, and this is really fast. In fact, let me show you how easy it is to get started with NATS. I can simply run a NATS server like this, and then I have a NATS server running. And then if I want, I could just start subscribing to a message by saying NATS sub hello world. And I could simply publish by saying NATS pub hello world, and then give it a payload. And NATS payloads are, completely agnostic. So if you want to use protobuf, you can use protobuf. If you want to use JSON or BSON or Captain Proto or whatever, I mean, you could use all sorts of different encodings. So I'm just going to use a string here, just saying hello, and you can see it's received on the other end. And I can, of course, send a bunch of them if I want to. NATS is really, really fast. In fact, when benchmarking, you could we have a built-in bench command inside of NATS as well. So I can just say NATS bench. Let's see if I can roll through my history real quick. Let's just send a bunch of messages here. And so NATS can send and receive a lot of messages in NATS core, which is really, really nice. And so in this case, we're about 3 million messages per second, which is pretty good. And I've gotten this up to 5, 6 very, very easily as well. I'm running a development version of NATS server right now on this machine. But as you can see, there's a lot of performance that you could get out of this kind of core NATS, this simple publish, subscribe. We also have request reply. So it's great for like microservice communication and things like that. But one of the problems that you might run into, or that you might have, seen in this iteration of NATS, is that it's not persistent. Meaning if this subscriber goes offline and this publisher just gleefully keeps publishing these messages, NATS will receive them, because really this publisher doesn't care about the subscriber on the other end. And so you kind of have this idea of temporal coupling, meaning you don't really have these publishers and subscribers don't really know about each other to the point where we can't guarantee that a message would be received. And so what do we need to do in order for that message to kind of make sure it's received on the other end? Well, then we need to start having to store these messages on disk somewhere. So all of a sudden, these NATS clusters that are generally pretty stateless, we have to start thinking about what it looks like to have state. Now, normally you would have a messaging technology that would either be completely ephemeral, like an easy pub subsystem, or completely durable. But the nice part about NATS is that you can have both of those things at the same time. And mixing those is actually very encouraged. And I think, Taylor, you'll kind of get into some of the use cases where you guys are using both of those things. You're using persistence, and you're using kind of also some of the core NATS stuff as well. And the fun part about this is all of this is, even our persistence layer is built on top of this still core NATS foundation that we have. So we're going to graduate from this very simple pub sub model for a second into one that requires a bit more persistence. And don't get too afraid by seeing a crazy graph, because I'll explain a lot of it. It explains a lot of things just in one go. But here is where we start getting into some basics around Jetstream, where instead of having a publisher and a subscriber, we now kind of change to terminology of like having a publisher and a consumer. So on one end, we might have, multiple, one or more publishers that are, publishing something. And like I said, now that we have this like, now that we have kind of this like state involved, we can it's kind of valuable to know when a publisher goes ahead and publishes something. In this case, they're making actually a request. They're getting a reply back that's saying pub ack, meaning your publish has been acknowledged, which is basically that's just saying, hey, I've received your message, I've saved it to disk, you're good, you don't have to worry about it anymore. And so the publisher is able to easily publish messages and have those saved to disk. And then the NATS cluster can then save those things on disk. And whenever a consumer wants to receive that message, they're able to do so in a slightly different way. And so we have a couple different types of consumers, but in this case, we're having kind of a poll-based consumer where this consumer will just continually request, hey, give me the next message, give me the next message, or give me the next set of messages. And NATS will kind of figure out what messages to deliver to that particular consumer. And so, and then the consumer, of course, and this is very standard in a lot of messaging systems, where a consumer will then acknowledge that it's received that message. And so there's a lot going on here. We have a publisher now, we have a consumer, we now have this idea of a stream, which is this kind of like persistent, persistent list or set of messages. But we have a lot of interesting things at play here. You could kind of see, maybe you've worked with something like Kafka or RabbitMQ before. A lot of this is going to look familiar. But we take these same NAT servers, and they're still clustered. But instead of just using our kind of like simple, clustering, it's now created, raft groups for both this stream and the consumers of that stream. And when I say stream and consumers, all the state for this, both the stream, meaning the messages inside of that stream, and then the state for the consumers, like, hey, how far along has this consumer consumed this particular stream? All of that state is stored on the server and is replicated inside of a cluster. And so you have a lot of choices as to how you want to replicate those things. Maybe you don't want any replication. You just want to YOLO it. And if that node goes down, that stream's unavailable. Most of the time, you don't want to do that. You want to be able to have you want to be able to have some resiliency built in here. And so you can replicate your streams across, all the nodes in the cluster very, very easily, and also replicate your consumer state. So when one node goes down, you have no problems. You can still read and write to that stream. Now, consumers are really interesting as well, to the point where, you might have this stream that's this set of ordered messages, globally ordered messages, but you might not want all of the data delivered to that consumer. You might just want a subset of it. And this is where NATS Jetstream really starts differing from technologies like RabbitMQ or even Kafka, especially Kafka, where Kafka is maybe just a fire hose that's sending you all the data inside of a topic. NATS and Jetstream, combining that with consumers allows you to have a lot of fine grain, kind of granular control over what it looks like to have a window into a stream. And so, for instance, this consumer, the actual stream might be storing all the messages inside of hello.star, but the actual consumer might only be concerned with hello world and hello Bob, and therefore those are the only messages that are getting delivered. These ones in blue here. So you can see 1, 2, 6, 7, and 8 are being delivered, and 3, 4, 5, 9, and 10 are being skipped over. The fun part about this is I could have as many consumers really as I want for that particular stream that could have different views or different kind of realities into the messages that they're seeing. And so you can imagine how you can scale this out, where you can have, this gigantic stream of maybe event data or sensor data or really anything, order data, and those things are being processed by microservices, and the microservices really can just create whatever consumers they want to be able to look into that particular set of data. And so at its core, that's kind of how the internals of Jetstream works. We have this concept of a stream, we have this concept of a consumer, and we're able to kind of utilize those to persist stuff on disk and create this more durable way of handling messages and events and things like that. Now, where this gets really interesting, and I think where we've really, really evolved a lot since, launching Jetstream, is we thought to ourselves, hey, we have this globally ordered set of messages, and we're indexing each of these little subjects for these messages. We can maybe create, something a little bit more sophisticated than just a stream of bytes. And so before I get into things like retention policies, I want to talk about materialized views for a second, because this is where NATS gets really, really interesting. Is you can use NATS for your microservice communication. You could use NATS for kind of your durable kind of queues or streams of data. But then you can also represent a key value store or an object store. And so, things you would normally use Redis or maybe MinIO or S3 for, you can actually use NATS to store all of this stuff. And so, if you were to take kind of a mental model of like all of this stuff is just a stream under the hood with a globally ordered set of messages, they all kind of have the same shape, but maybe the actual subjects themselves look a little different, but the expression of these can actually look quite different, and the ergonomics can look quite different, where you can think of a stream as maybe like a really standard array, right? It's just a big list of messages. Sure, there's some differences there, but like in a very simple mental model, it's just a big old set of messages. But then you could think of a key value store where you're breaking those messages down into maybe more of an associative array. In this case, we have a key value bucket called foo, and inside foo, we have the key Jeremy and Byron and Bob, and each of those has entries. So we have key value with actual history, right? But you could still, put keys, delete keys. You have, more atomic operations as well, which is great. And so you get all of these really fun ergonomics. And graduating from there a little bit, you could even do stuff like an object store where you're taking an actual image or PNG that's maybe a big in size, and you want NATS to be able to chunk those up into appropriately sized messages for speed and performance reasons. You can do that, all with an object store. So, this is kind of how it's represented in a kind of a very under the hood sense. But the ergonomics that you get from NATS, you're able to just use these as part of the SDKs. You'd use it like you'd use Redis, or use it like you'd use something like S3, where you're just kind of uploading objects or setting keys on a key value store. But you get all the benefits of the fact that this all lives in NATS, and it's all messaging based. So I can actually, for instance, watch this key value store and say, give me all the updates. Whenever something updates, I want a live view of it. And this is what makes these constructs so powerful, is that I can build these, I could build and utilize these material views, kind of use NATS in a multimodal way, to where a lot of the requirements for my applications, whether it's a database or a stream of stuff, or a queue, or a key value, or an object store, or microservices communication, all that stuff can actually be handled inside of NATS, and you get all the benefits of the uniformity and security and flexibility that it provides. And so I know I just said a whole lot of stuff, but I'm going to jump in and do a quick demo, and then I'll hand it off to Taylor, and we'll leave some time for Q&A. And one thing I want to put in there as well is, like, I'm happy to also just show. I like to show and not tell. And so if you have questions and you're like, can you show me how to do X or show me how to do Y, I'm happy to just like demo it in the CLI, because it's really fun to do anyway. But let's kind of look over some of these, because I think this will be fun to do. So I'm actually gonna use the NATS CLI for this. I might jump in and write some Go code if we need to. But just know, like, all the stuff that I'm doing inside of the CLI, you can do inside of a client SDK. You can do it in JavaScript, you could do it in Go, Rust, Python, Java, C#, all of that stuff. And so we really wanted to make NATS this kind of unified platform where entire multiple developer teams or entire organizations can really lean on NATS and NATS Jetstream to kind of be a big part of their developer platform. And so, yeah, you could write these in any language you want, but we're going to use the NATS CLI, which just gives you a ton of really cool tools for monitoring NATS, for working with NATS, but especially just being able to like prototype. NATS, one of my favorite things about NATS is that it's really fun to play with. And I encourage everybody, as they're going through their NATS journey, to think about it in a way where things are more fluid and flexible. Instead of thinking, oh, I'll get a POC up in a couple days or whatever, you could really put together, proof of concept of something you're thinking about architecturally in a matter of minutes, because you're using something like the NATS CLI. And so I already fired up a NATS server, but I'm going to close this down. I'm just going to put in the JS flag to enable Jetstream, because not every NATS server, needs to have persistence, and you can mix and match your different types of NAT servers in a cluster. We have to be explicit about saying, yes, we want to persist data. Okay, so NATS Jetstream is running, and now I can simply say NATS stream list to list out my streams. And I don't have any streams right now in this NATS server because I just fired it up, but I can say NATS stream create, And what this is going to do is it's going to just run me through like a quick wizard of what I want to do with my stream. It's going to run through a bunch of configuration options, most of which I'm going to just keep, keep as the default. But I'm going to name my stream, let's just call this events, or actually let's call this orders. And then it's going to ask, what subjects do you want orders to listen on? And since NATS uses this concept of subject-based addressing, I can use stuff like wildcards, saying, everything that's kind of like orders.star or orders.greater than, which is just a catch-all wildcard. But I could do, lots of fancy stuff like that. Or maybe I want to say, the region is here, and then the actual, order ID is here. You basically anything you want to be able to kind of sort of index on or query on or wildcard on, you want to include in the subject. In this case, I'm just going to do orders.star. It's going to ask me, do I want to store it in a file or in memory? My replication factor. I'm not going to go over retention policies just yet, but we'll just keep going through all of this. And now we have our stream. I'm going to say nat stream list, and we have a stream now. So we can have multiple streams, and then multiple consumers for those streams, which is pretty fun. Let's go ahead and put stuff into this stream. So I could just say nats. I could simply publish these messages like this. You could say nats pub, orders dot hello. I'm just going to say hi, and we'll just put in a bunch of them. All right, we have 10,000 messages now. I'm going to say nat stream list. And you can see we have 10,000 messages in our orders stream. I can, of course, say nats sub. I just want to subscribe to this stream. And you can see it just receives all those messages. And the cool part is it doesn't just read the messages, but I can, of course, publish more messages here, and it will receive those messages. So this is kind of a very high level take on, okay, how do I put messages into a stream and get them out? But there's a lot of ways that you can configure these consumers, and you could have a lot of fine grain control over how you want to consume data from that particular stream, how you want to filter down, and stuff like that. So that's a stream at a high level. But like I said, we have stuff like key value stores, object stores, all of that. And so we can actually say nats, we can say nats kv add, and I'm just going to call this bucket, foo. Now I have a kv bucket that I can start inserting stuff into. I could say nats kv put foo for the bucket, and I could just say, hello world. So hello is the key, and world is the actual value. And now I can say nats kv get foo hello, and get my result back, which is nice. The cool part about this, like I said, is I can say kv watch foo. And when I start putting more values into here, you could see that I get results there, which is really nice. And I even get messages for, when something's deleted or when something's updated. And so you can imagine building applications that utilize these constructs to kind of have more of a, live state that gets updated automatically. You could use KVs as a cache. You could use it as a database. I use it as a database in a lot of stuff. I'm actually building a to-do list application for my own personal project, and the sync server is all built on NATS KV. And I'm sure Taylor will share a little bit more about how much you guys use KV. I know we have plenty of people that are using it for like configuration management because it's so good for that stuff. Before we get into that, let me just quickly demo Object Store, because Object Store is pretty cool as well. I can just say nats object add. Let's just call this images. So now I created a bucket called images, object list. Oops. That's object list. We have a bucket called images that doesn't have anything in it. I can easily put something in it by saying nats object, what is it? Nats object put. And I have an image here somewhere, I think, title.png. I think this is like a 4 megabyte or so PNG. So I'm going to say nats object put title.png. Whoops. Images, title PNG. And so it's now uploaded that. But the cool part is it's actually taken this 4 megabyte file and it's chunked it out into multiple messages. And the reason for that is because NATS has an upper limit as to how big a message can be. And this is for kind of networking and performance reasons. We want to be able to chunk a lot of these things up so we can move them around a lot better and replicate them a lot better. But you could put very, very large objects in here, which is really, really cool. And so I can obviously, get this image, but I can also look kind of under the hood as like, well, how does NATS kind of break this down? Because this is a stream under the hood, I can simply say NATS sub, um, stream KV images. And I don't want to break my shell because it's going to output some compression stuff. So I'm going to say headers only. Just deliver me only the headers to this stuff. Stream
Stream, yeah.
object images. There we go. And this is going to give me all of the messages that it's created for that particular bucket, which is really, really cool. And so you can see under the hood, all of this stuff is using NATS pub sub. It's saving these things to disk and using streams. And then we just kind of build up that foundation from there. And now we kind of have this multimodal capability inside of NATS. Combining that with something I didn't even talk about yet, but I'm sure you can cover, Taylor, is like the fact that NATS can scale into like this very, very kind of global topology, which makes it really, really important for things that are going out to the edge or going multi-cloud or going multi-geo. And so, Taylor, I'm happy to hand it off to you if you want to kind of share some things, and then we could do some Q&A and keep writing code or doing whatever.
Yeah, perfect. So just before we move on to some of the stuff I'm going to show, we did have some questions. Someone had asked if you could provide any info or materials about the topics we're covering here. Is there anywhere people can go to kind of look at some of the like diagrams and things you've shown off today?
Yeah, great question. So, we have our you can go to nats.io, and that's where our docs will be. Another place to look would be on YouTube. You could search Synadia, which is just right here in my name, right there. Our YouTube channel, which I do a lot of videos on that explain all of these topics in depth. And so, you can kind of go through the videos in order for the most part and get a lot of value out of them. I know a lot of people get value out of them, and I have, diagrams and code examples and all those things are pretty accessible.
Yeah. Okay. There's been some other questions about auth callouts. Now that is a deep topic that I know Jeremy can go into. I can actually go into as well. We can probably save some time at the end to talk about that for those of you who got that on the stream.
Yeah, and a quick hint is an auth callout video is coming soon. So I'll be covering that in also very great detail. But auth callout, just for those who don't know, NATS has a lot of different ways that you can do authentication, authorization. One of the preferred ways is actually to use kind of this more decentralized JWT-based auth, which makes it very scalable to hundreds of thousands, if not millions of clients. But it can be a bit of a pain to kind of configure and set that up for yourself. And auth callout is one way to make that a bit easier, as well as kind of integrating it with maybe an existing authorization system like an IDP or stuff like that. And so it's a huge topic, and auth is just a huge topic in general that is hard to talk about on streams. But yeah, we'll have a video coming soon where I'll cover it.
Awesome, great. And then someone had also asked about good practices for the production environment and how to set those up and documentation for that. I'm going to actually stab at this first real quick, Jeremy. I'm actually about to show how we do that for some of our things, including setting this up in code. And it's actually going to be even more interesting because the project I'm going to show is written in Rust, and it still works the same it's the same idea. And so I can show some of this working in code. But did you have anything else to say about if you're productionizing NATS, how would you go about that?
Yeah, I mean, we have a lot of general tips for productionizing NATS, but we also have a lot of good resources available. The reality of it is that NATS is so flexible. Productionizing could mean a lot of things. So we do have some general guides of depending on the environment that you're working in. If you're working in Kubernetes and you want to use a Helm chart, we have a pretty good Helm chart that works great out of the box and is pretty flexible. But also plenty of people are deploying NATS on very small compute devices. You can have very arbitrary topologies. So one of the things we are working on is just how can we make it easier for you to go from zero to a reference architecture. And so stay tuned for that. We have some really cool things that we're working on in the OSS space, especially with the NATS CLI, which I just showed, that allows you to kind of just pull up an architecture. But productionizing it, we do have some general guides, but we've really tried to stay pretty agnostic. We work and play really well with Kubernetes, but we are certainly not a Kubernetes only option, which might seem a little weird from being a CNCF project. But we have plenty of people that just run, NATS via systemd, or especially if they're in an environment where full scale Kubernetes doesn't necessarily cut it. That we're able to support a lot of that. And so as far as productionizing, I wish I could have just a very simple answer for it, but it very much depends on your environment, what you're trying to solve for. And we do have some best practices covered in our docs, and we'll continue to have some more of that as well.
Yeah.
I'm looking at some of the questions too. Do you provide paid consultancy to run NATs for custom needs? Yeah, if you reach out to Synadia or you go to our website and fill out our form to contact us, we help a lot of organizations, with their with managing NATs, whether it's inside of their own VPC or they're wanting us to kind of run it for them. We have a lot of options there. So we have Synadia Cloud, which is a fully SaaS managed offering, but then we also provide other services. So you don't need to, but if for some reason you are running NATs in production, we'd like to know that you are, because we get surprised all the time being an open source project and be like, we're running NATs in production, we're super happy, and we've just never heard of you. So
yeah, that's a common problem, and that's something to point out here is that both Jeremy and I work for companies where we're big supporters of open source. We're what they call the open core model, where we have a very strong open source thing, and then there's additional like the enterprisey or hosted features that come with our different platforms and things. And so there's always ways to get help with this, and the NATS community is fairly large and vibrant. There's a Slack channel. There's Slack channels you can reach out into. You'll find both of us there.
yep.
There's all sorts of resources you have, and I'm going to go into some of the crazy things you can do that Jeremy was mentioning here. So I think I'll go ahead and dive into that. Please keep your questions coming. I'll either answer them in line or after we get through. But yeah, great stuff here. So let me go ahead and share what we're doing. So ours is going to my part of this is a little bit interesting, because there's probably some out there who haven't heard of either WebAssembly or Wasm Cloud. So I have to give the oh so slightest introduction to this to explain why this is so interesting. But let me go ahead and kick off here with, well, what is Wasm Cloud? And like Jeremy, I like to kind of show this. This is a live stream. I'm not going to shout slides at you. I want to show like what we're doing. And this is the Wasm Cloud main repo. It's the main. It's a fairly large mono repo for our project. And now Wasm Cloud is basically a distributed application platform based on top of WebAssembly. And WebAssembly is a compilation target. It's a very small binary. This in and of itself, like I said, could be its own discussion, which we might do in the future as well. But suffice it to say, we make it so you can take your WebAssembly and run it anywhere. And one of the key things underneath the platform that we run is NATS. NATS is how we do this. And when Jeremy started showing this all off, he was talking about the pub sub aspect of this. And it means that it's entirely location agnostic, has no idea where the other receiving end is or if the thing is going to receive it. It shoots those topics out and then allows something to subscribe to it. And so you are basically creating a massive cluster. Now we call our cluster something called a lattice, because it's kind of like a linked together set of nodes that could be in any region or in anything or running anywhere. And I'm going to show a diagram to explain what that is. So we have something called a Wasm Cloud host, and a Wasm Cloud host can run on. Sorry, zoomed too far. A Wasm Cloud host can run on all sorts of things. It can run on your own custom hardware. It can run on Kubernetes. It can run all sorts of things in any type of cloud environment. And these hosts run, and they're able to connect things across. Now, this is an example of a key value application, and I'll show this locally in a second. There's the whole geo failover and all the things that we enable are really cool, but are not the feature of this. But the feature element of this stream. And so what I just wanted to show is basically what's happening is we're using NATS underneath the hood to do this. Many cases we're running what's called a NATS leaf node, and this is just a NATS process that's running locally that's connected to a larger cluster. And these these leaf nodes can then be connected to that cluster and jump across depending on where it's at. So in this example, we might have something like a an application that's running like a WebAssembly application. This is WebAssembly things that are drawn in here, that are connecting to built-in capabilities or capabilities that are provided basically globally. I could have Redis running on one, like, a local, this is like a Raspberry Pi or something, and I could have S3 connected somewhere in Kubernetes. And it doesn't matter where those applications are. The WebAssembly module over here on the upper one can be connecting to an S3 bucket that's connected through Kubernetes, and something on Kubernetes could be accessing a Redis database that's in your local data center or running on your Raspberry Pi. All of this is kind of enabled by what NATS has underneath the hood, and this allows you to get this geographically distributed thing. And this is the only mention I'm going to do of it, but you can. This is one of the hub spoke models, and like Jeremy said, it is incredibly flexible. That's one of the biggest strengths. It's also a difficulty for a lot of people coming into NATS. It's like, wait, how do I do it? And it's kind of like, well, you can kind of do what you want with it, and that's the whole point. Is that we're as flexible as NATS is flexible with its deployment. And this could be an example where each of these little Wasm Cloud hosts are running in the EU and inside of the US, and they're connected through these gateways, and everything in here to a piece of code or to an operator appears as if it's one essentially cluster. That's why we call it a lattice. And so that's all really cool, but we had to have something that manages this. Now, WebAssembly is built on a cool technology called components, and components use what is called a WIT file. Now, I'm going to go ahead and come over here and show what this WIT looks like. I'm going to embiggen this. Give me 1 second. Don't want people to have to squint at their screens. And so over here we have this. This is what's called a WIT file. Now, WIT is a WASM interface types, and it lets you specify things with concrete actual concrete actual types that allow you to use these in any language. And so when you create a component, these things let you do, like if we do the key value, you're coding against and basically an interface at all times. So you don't know necessarily what's on the other side. So in here, we have like a key value one. It looks exactly like you'd expect it. Get, set, put, delete, or get, set, delete exists, like those kind of functionality things that you'd expect from a key value store. Now, the reason I'm telling you this is that this is very different than how you build applications currently. This is something that is a standard. It's a W3 standard. We implement and run on top of it, but there's nothing that knows how to actually leverage this. And so we wrote a tool called WDAM or WADM, depending on your thing. I call it WDAM. That's why it looks like the punch from a superhero like a comic. But it is the Wasm Cloud Application Deployment Manager. And this gives people a familiar way, YAML, for all we love and hate it, to deploy applications. And this manifest actually looks very, very familiar for most people who've done it. This is the OAM style manifest, which is also an open standard, and lets you specify things. So you have to have something that's knowledgeable of, hey, how do I link these things together? How do I connect something that needs to talk to? I implement it against a key value interface, but what's giving me functionality, like connecting me to Redis, as in this example. And so you needed something different than what's currently available. But we didn't want to reinvent the wheel here. We're not reinventing a full like scheduling thing and leader election. That's something that we can actually get already through all the awesome things that Jetstream does for us. Now, like I said, this is a gloss over of what we're doing, but I need to explain some background around why this exists. And it exists because you need something that's components native, that understands how these WebAssembly components work, to be able to show how they can be orchestrated and connected together. And so that is why we built WDAM. Now, what's interesting about WDAM is that all it is on top is just a reconciliation loop, just built on top of Jetstream and other NATS primitives. And this is basically the loop. I know people like diagrams, so I made sure I had one here. You deploy these things, which are called scalars. Those are those things that are listed in the YAML manifest. It does a reconcile, and then it waits for Wasm Cloud events and keeps going through that loop. It says, does it match it? Then I'm good. Does it not match it? I'm going to reconcile. And if I can't reconcile it, then it's in a failed state. Very, very similar. This is just the reconciliation loop we're kind of all familiar with inside of a tool like Kubernetes. Now, what's actually going on underneath the hood is a lot cooler, but I'm going to show that diagram in a second. I'm just going to go ahead and run it. So we have a cool tool called Wash. This is our CLI for Wasm Cloud. it is a open, like I said, open source tool, and it comes in with a bunch of basically open source tooling built in, as well as just all the functionality for Wasm Cloud. And we have a tool called called or a all the tools bundled in. Sorry, having a hard time speaking. We have all the tools bundled into here that you need to get started, including WDAM, Wasm Cloud Host, and NATS. And so this makes sure all of these things, you'll see that it's actually starting NATS in the background for me, and then it's starting a Wasm Cloud Host. So now, normally, if you were going to try to do this, the API that it exposes for you is very dumb, and this is on purpose. Everything is done via events that are published in the normal pub sub pattern that that Jeremy was showing off at the beginning. So if I just go nats sub, and then I do wasm bus dot caret. So the caret symbol says I'm going to capture all. It's the wildcard matching. It says I'm going to match anything that's starting with this prefix. I'm going to go ahead and sub to this, and I'm going to wait just a second. It'll take 15 to 30 seconds, depending on if I missed it. And we're going to start seeing events from the host come in. And so what happens is everything inside of this is event driven. We have the most drop dead simple APIs on top of this. They're not smart. They're actually dumb APIs that sit on top of this. And then you're able to create something that orchestrates. You're not even locked in to using the WDAM stuff that we've created. If you want to build your own orchestrator and use NATS and do all sorts of things, you can do that. But right here, you'll see that it's publishing on a host heartbeat. And I'll keep this up so we can come back and see some of the stuff that's happening as we do this. But essentially, we're using our whole API as a NATS pub sub API. There's specific topics that you use, and you're able to call those. Now, WDAM gives us the ability to do all these things I was talking about, but it does some really cool things underneath that. I'm going to show it working, then I'm going to show some of the details underneath. So I'm going to first just take a simple, actually, I'll do the key value one. I was going to do it in hello world first, but I'll do the key value. So I'm going to just do a simple key value counter example. This is coded against that key value interface I was showing. And I'll go ahead and wash build this. So this is using open source tools to make sure it's there. And then I'm going to see wash app deploy, and then wadm.yaml. And actually, I will show this too, just because we have it. We're going to say nats sub wadm. Okay, and so this is going to subscribe on all the API topics as well, so you can see this actually happen. So I'm going to go ahead and wash app deploy this. If I come back here, we'll see that there's a whole bunch of stuff that happened. And then also over here, we're going to start saying, oh, hey, I'm setting up links. I'm getting health checks. I'm getting all this stuff. And so all of these things are what WDAM is actually using to react to the different changes that are going on. So what you'll now see is that I can, like I said, okay, I'm getting a host heartbeat. You can actually see that there's some new stuff on it. I can show you that it's running by getting the inventory from it. And we can see right here that it's running some things that are providing HTTP capabilities, Redis capabilities, and then also the code that I just compiled and was running. And so all of this was just created, and I'm able to spin it up, and I'm also able to kill it. In fact, it works fast enough that if I just go ahead and stop one of these, so if I do wash stop, so this is me using the low-level API component, and then I give it this, and then I try to get the inventory, it's probably already going to be back. Yeah. So basically, it got the event and then reacted and then changed and reconciled back to where it should be. So we get this really powerful system that is just that reconciliation loop. But because of that global nature of NATS, it can reconcile these things globally. And I'll show some of the cool things there, but let me go ahead and show what the streams look like underneath the hood. So if I do NATS stream ls, which is some of the same, like I said, I'm using the same tooling that Jeremy was just showing, you'll see a bunch of different streams here. Now, these streams are how we make sure that we're getting work done. Now, there's a couple of these. One of these is a mirror that captures some of the events. This is us actually, this stream will be going away relatively soon because 2.10 added some really cool mirroring features that we're not even going to have time to go into. And then we have a couple other streams that are really important. The first are the events, and this is the one that captures all these events that I was showing you in the beginning, and then make sure they get published as part of a work queue. So everything in here is actually selecting, and I'll actually get the stream info for this, because this is where you get to. We had seen a question in the stream about how is NATS different from Kafka. This is where you start to see these subject filtering and things that really show the difference between something like NATS and other tools that exist right now, like Kafka. So I'm going to do NATS stream info. Did you want to say something there, Jeremy?
Oh yeah, I mean, just to add on to that, I think the biggest difference, if you are familiar with Kafka, is I mentioned it a little bit, but Kafka is a fire hose in terms of what it delivers to clients, and so what that typically results in is there's a lot of upfront design in order to be like, well, what goes into what topics and when and where and how do I partition this stuff up front. There's a lot of upfront design in order to kind of make for an efficient Kafka system. I think what you'll see that one of the big themes around NATS is this idea of kind of fluidity and flexibility. Typically people will be like, well, how do I create my topics or my streams in NATS? And in general, especially if you're doing kind of a more conventional thing, it's very idiomatic to be able to say, hey, create one big stream and just filter down those consumers. So you don't have to separate your events out into topics for efficiency's sake, because you can actually create that efficiency inside of the consumers themselves. So that's like one big difference between Kafka. But the fact that NATS is multimodal and has a lot more flexibility, the Kafka, again, is really an append-only log and a fire hose to be able to consume those things and whip through them as fast as possible. And so you may be able to have more throughput performance in terms of Kafka. NATS kind of gives you that more of that flexibility. And I'd say the other big difference, and Taylor kind of leaned into it, was this idea of all that idea of location transparency, being able to have all these arbitrary topologies of servers and failover and stuff like that. That doesn't just extend to the pub sub aspects of NATS. That extends to the jet stream parts of it as well. So you can think about all the different ways that you can have your data. And obviously it gets a bit more complex because data has to live somewhere, right? It has to be on disk somewhere or in memory somewhere on some machine. But we do give you all the tools to be able to say, hey, I have this data here and I want to be able to replicate it. And you have so much flexibility in terms of, I want to be able to replicate it in my cluster and have that be immediately consistent, versus I want to be able to replicate it outside my cluster and have it be eventually consistent. You can decompose streams into much smaller streams that are filtered. You can compose streams into much bigger streams. So you have a lot more flexibility in terms of where your data lives, how it moves around, and how it kind of composes and decomposes, which is like, we've seen that's so important for these highly distributed applications that may not be running always in a 3-node cluster in the cloud, in the same cloud.
Yeah, and the thing is this allows for flexible deployment of WDAM as well. You can have multiple running all over the world, balancing the work. In fact, I'll actually jump to that right now. So this is me build. I just built. WDAM locally just to show this running. I'm actually gonna do just so we can look at this if we need to later. Okay, so I'm just going to run this, and you'll notice I passed absolutely nothing to this command line. I have a bunch of options I can do, but as long as I can connect to the same NAS cluster, I can spin up basically a fairly linear scaling. Just I can keep adding more WDAM instances to handle the amount of work, and you can actually see this is super verbose mode on purpose. You can see it like fetching configuration and handling events. So now this is what I was going to show over here. You have this. Where did I put it? Right here. Sorry. This NATS stream info was saying, hey, this is a work queue. So I'm essentially popping work off the queue filtered by subject. And we can see this by saying NATS consumer ls consumer. If I can spell today, man.
Oh, it happens. It's a curse. It happens to me
I
all the
know.
time.
Okay. So if I let's go ahead and get the consumers for not that, for the event stream, and we have one right now. So if I do NATS consumer info, that's gonna be. I always forget you have to specify both, and you can actually see that this is filtering on the lattice here. So this is a multi-tenant system by default. Every lattice has its own ID, and so then I'm able to go through and say, oh, I'm going to filter for this one or this one or this one. And so each lattice is only handling one at a time, balanced between these two things. So this all looks kind of like this. This is the kind of crazy thing. A user can deploy this. it validates it, and then we also use, which I forgot to list here, the key value store. And the key value bucket, nats kv ls, and you can see here I have these two buckets that are for WDAM. And this is where we're storing the state. So we synthesize the state of our lattice at any given time, and we store these manifests that are given. And then we have an event stream and a command stream that these might be merging soon. And then we have a status stream. And a status stream is the more standard stream that Jeremy was showing before. We keep the history of statuses of each of the applications so that you can see like the status history over whatever amount of time. By default, we set it to 10 before the messages drop off, but you can actually configure that to be whatever. You could keep history for hundreds or thousands of different events that come in. And like I said, I can't like dive into all those details. We don't have the time to do that, but we're essentially leveraging all of these different applications to then be able to scale. So when you combine this type of thing, because it's all event driven, the only state that actually matters is your manifest. Everything else can be entirely nuked and lost, and the thing will pick back up again once everything recovers. And once you combine this with the power of something like this geo-aware supercluster idea, you start to see some of the crazy things you can do. You can have WDAMs running in different areas, and then you can have these things balanced across it. You can have failover. There's all sorts of really interesting architecture things that can start to happen. And so that's one of those powerful things that NATS lets you do when you build on top of it. And this is something that we have multiple open source users that they run this, and they run this in production. And it can glue into things like Kubernetes. We have a Kubernetes operator, and you can actually kube control apply these if that's your flavor of doing things. Or you can do just use the API directly, or you can use Wash. All of these different things allow you to connect and then start to put everything together. So I wanted to leave time for questions. There's plenty of questions going on in the discussion in the chat. So that was kind of where I want to stop for there. But essentially, just to drive home the point, NATS lets you build these very flexible systems, and it lets you use things as a work queue or as just a stream of data to keep around. And when you build on top of these primitives, you're able to build some really complex systems with there's less complexity around managing essentially the clustering or how things communicate to each other than you would probably ever be used to with any other type of system. You're able to just basically connect it, and then everything starts working. That's how our Wasm Cloud hosts work. That's how WDAM works. It's all just by connecting to NATS and then leveraging those NATS primitives to do exactly what we need. So
yeah, this is really cool, and it's one of the use cases I know we've wanted to continue supporting for a while. I know we even have a question that came up that said, is Wasm Cloud somehow related to Nex? And for those who don't know, Nex is a project that we've been working on at Synadia called the NATS execution engine. You could run workloads with it, but we've designed it to be very low level in a sense where we want people who are kind of building platforms to be able to take advantage of it. We're not trying to create some sort of higher level thing out of it. But it's a good way to be able to say, hey, I have this ELF binary or this, WASM workload or this, JavaScript, function that I want to run in kind of like a FAS kind of way. And you have these nodes that you can just run them anywhere. So it's similar-ish to Wasm Cloud. And I believe you guys are taking advantage of Nex in some ways as well.
I know that some of the other different maintainers who are not at Cosmonic have also actually they told me, I haven't seen it, have gotten like Wasm Cloud running because Nex runs ELF binary, so you can just literally compile down the Wasm Cloud host and have it run and other things like that. And so like it is a low level primitive, and that's I want to really enforce that. Like in response to the question is NATS is very good at providing these low level primitives for us to build on top of. And you're able to combine those and use them in whatever way is best for your use case. And so there's a lot of learning here, and I could go on for probably another hour about all the different things and the nitty gritty details here about what's going on, because it's actually really quite cool when you see it in action. But when it comes down to it, it's all just still these basic NATS primitives combined together in the way that works for us.
Yep, absolutely. Yeah, I think describing it as low level is a good way to go about it. It's trying to solve these hard distributed systems problems with some low level primitives, and so you might not, I don't think you should expect you'd get like Vercel level high level developer experience out of this, because there's a lot of concepts to still learn and pick up. But where we've seen folks be really successful with Nats is where they're building these, internal developer platforms, or they start with one thing, maybe simply using it as KV, and they're doing something big and distributed. And all of a sudden, people start perking their ears up and saying, oh, we could use it for this and we could use it for this. And then all of a sudden you have your entire organization just leaning on Nats, and it's providing a lot of benefits. Because honestly, the alternative to a lot of this is like, we try to run all these workloads, and then we put it's kind of a more backwards take. Nat starts with, how do things communicate? Let's rethink that, and then let's figure out how data gets shuffled around, and then let's figure out how to run our workloads. Like we kind of went backwards in terms of how most folks do it, where most folks are like, let's run our application. Okay, now we need to figure out how to run our database well, and replicate that and everything. And then we need to figure out how all of our applications talk to each other. And we fundamentally think that there's flaws in thinking that way, because what you end up with is when you're starting with the workload, that kind of becomes your centralized piece that you base everything off of. And what you end up with is like centralized databases with maybe some maybe some read replicas. And then you have load balancers everywhere. You have maybe a service mesh or things like that. And I think this is where I can become really opinionated, is like, because we thought about it a little bit backwards, it actually leads to a lot of simplicity at that far end, where you're able to run applications literally anywhere, have them connect in and talk to each other without, running a million load balancers. You just have a NATS cluster that's handling all of that, and you can arbitrarily put them anywhere that you want. So there's a lot of real cool value around that.
Yeah, I think the best way I've put it, and this is why Wasm Cloud uses NATS, is that we've often had dumb networks and smart clients, and NATS inverts that. You have a smart network and dumb clients,
Mm-hmm.
and I think that that's the key thing here. So when we build, uh, what I was showing is that we can run a key value application. I didn't even get to show the full demo because I was trying to show the NATS parts of this, but the the point is that because it's using NATS, I can even connect to databases that are not like running in NATS. I'm still connecting to a Redis database, but there's no load balancer aspect to this. And you're able to essentially shape your traffic depending on how you built your NATS cluster. And so NATS is at its core, and what it's very good at is this being essentially the smart network here, the smart thing that connects everything. And then you get to build tools like Wasm Cloud, which is an application platform, that higher level thing that run on top of it. And that's why we really wanted to do this stream together, was because it shows that relationship of what you're able to do with these things. So great questions there. There was another question that was a more technical one around saying, can two leaf nodes share streams and consumers without being connected to a third non-leaf node NATS? If those two are connected, yes, there's a concept called domains. JS domain is what the flag is. We use them quite a bit, actually, at Cosmonic. And you're able to do some really interesting things because you can have different domains represented within the same NATS cluster. And you're just saying where it lives. So in the example that's given, where you have two leaf nodes that are hosting streams and consumers, they're essentially acting as a small little subcluster of the bigger cluster in that case, if they're set to the same JS domain. They don't need to be connected to another one. But let's say that, like, you could have a JS domain called main, and then you could have a JS domain called like local, and the local one could be across those leaf nodes, and the main one could still be up there, and you could still access both depending on how you configure your things. And this is all done in code. Like, you can look, if you want examples of configuring streams and doing some crazy stuff with that, you can take a look at the WDAM code base. Like I said, we're pretty much leveraging like subscribers and consumers and publishers and all sorts of stuff in there, and you can see like the different ways we configure and put the things together.
Yeah, you can configure, like I was creating a stream inside of the CLI, but you can do all of that stuff inside of the code. And there's so much configuration that it's overwhelming at first. I have a video on it, but to that point, like the whole leaf node thing, you have so much control over where your data lives and how it gets replicated. And so even that simple question of, can two leaf nodes share stream consumers? It's like, well, that depends. Are they going to mostly be connected to each other? And so do you want to put the data over here and have the stream and consumer being, or the consumer being consumed over here? Or do you want them each to have their own replica that they can write to? Like, you can still do that with a little bit of fiddling with the configuration. There's a lot of really neat ways that you can provide for that. So being able to combine those streams or source those streams, multiplex those streams across leaf nodes and across clusters. It's all very possible, which is why when somebody asks, hey, how do you productionize this? Like, oh, it totally depends. It totally depends on what you're trying to accomplish, because these are such low level primitives that can be composed in like various ways. And what we're seeing at Synadia is like, right now, there's no way to just stamp out an edge deployment. And I'm sure you guys are seeing this too at Wasm Cloud, where it's like people are coming to you with the requirements of what they need for the edge, and we're
It's
seeing
different every
similarities, but
time.
there's lots of differences right now because everybody's still trying to figure out what that looks like for them. So very, very interesting stuff.
Yeah. And so we're getting here to the end. There's one last question that came in running Wasm apps in the browser using a Wasm Cloud runtime that's connected to Remote's NAT server. The answer is yes. We've toyed with a browser runtime before, but that is a fun question. So I invite you to come to the Wasm Cloud Slack. You can find that on the Wasm Cloud webpage to get some more there, because that's a really good question. So everyone, we're at time. Thank you so much for coming and for the great engagement today. We loved the questions. If you have any more questions, please feel free to reach out to Jeremy or I. We're both on the NAT Slack. I'm inside of the Wasm Cloud Slack and the CNCF Slack if you want to reach out there as well. And so really, really great conversation, everyone. And thanks for being on today, Jeremy. And
Yeah, thanks for
we
having
will
me.
see you all at the next stream.